Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Introduction to Data Analysis in our Part 5. Now we have the link to the material down at the bottom, and when you go to the Part 5 and looking at data analysis, you will come to this page. Now up to this point, we have just been learning how to read data and make it tidy. Now this was a lot of work indeed. We're now at Part 5 of this workshop. Now the payoff is that now that we've tidied the data up, it means the analysis is going to be much easier and much more straightforward. Now this is intentional. Data cleaning is the messiest and most ambiguous part of data science. A truism is that data cleaning probably takes 80% of the time of any data science project. However, without this effort, data analysis and visualization would be similarly messy and time consuming. By cleaning and tidying our data first, we can then perform data analysis and visualization using clean, consistent, well-tested and tidy tools. Now to do the analysis, we're going to continue on from our cleaned historical data. So I'm continuing on in this workshop, in this notebook. And to do the analysis, we're going to use the summarise function. Now the summarise function is part of the dplyr package and is loaded automatically with the tidyverse. And it creates a new tibble, which is a summary of the input tibble based on the grouping and summarizing function. Now, summarizing functions include mean, calculate the mean average, median, calculate the median. We can do standard deviations, minimum and maximum, etc. And again, we have the links here to all of these functions. So, for example, if we wanted to calculate, say, the mean average temperature, we would take our data, historical temperature, and we're going to pass this through the summarise function, where we're going to create a new column, average temperature is equal to the mean of the temperature that we have here. And then we're going to say, if you see any not available answers, just remove them. So don't include NA values when you calculate the average. When we run this, we've now created a new tibble with just one value and one row, one column, one row, seeing the average temperature across the whole of this set is 9.2 Celsius. Now this is calculated the average temperature just of all of the data, but what if we wanted to group data together? Maybe we want to calculate the average temperature of every single year. Now we can do that by using the group by function. And then from the group by, we can then pass that into summarise to calculate the average. So we're going to insert here group by, and the argument to group by is the column we wish to group by. So what this means is that all of the values with the same year are going to be grouped together into the same group. When that's then passed to summarise, summarise will then calculate the summary for every single group. So if we then run, we can now see we have the average temperature for every single year. So much easier now that everything is tidy. Now we could, if we wanted to, rather than group by year, we could group by month. So we did here group by month and then run this. We can now see these are the average temperatures for every single month across the entire data set. Now obviously calculating the average temperature for every single month between 1700 and 2020, there's going to be some change there. So maybe what we want to do is to ask questions like, what was the average temperature for months in the 18th century versus the 20th century? Now to filter out particular rows which will then group, we can again use that filter function. So for example, if I put the filter in here first, so we're going to do filter, let's now filter out all of the years, all the columns where the year is less than 1800 and the year is greater than or equal to 1700. So that will pull out all of the years which are in the 18th century. It will then group them by month and then it will summarise. So here, these are the average monthly temperatures in the 18th century. Now, of course, we could repeat this for the 21st century by saying, let's do every time where the year is greater than or equal to 2000. And have a look. Here we are, these are the average monthly temperatures in the 21st century. And indeed, let's make this even more explicit by saying 21st century as the column name. There we are. So I've walked you through now some basic analyses and grouping and filtering, and this has brought us down to the exercise. So what I would like you to do is I would like you to use filter, group by and summarise to create tables that contain the average monthly temperatures for the 17th and 21st centuries. I would then like you to take the difference of these to calculate the change in average temperature for each month. Next, I want you to calculate the minimum and maximum monthly temperatures for the 17th and 21st centuries, and again calculate the change in minimum and maximum temperatures for each month. Finally, what is the average increase in maximum monthly temperatures between the 16th and 21st centuries, between the 17th and 21st centuries? So again, press pause, and when you come back from pause, I will show you the answer. Okay, you've now unpaused, so we're ready to have a look at the answer. So we're going to work continuing from this worksheet because we already have historical data loaded up. Remember, we've read it in as read table, we've loaded up the tidyverse, which has been in there, and then we've just played around, we've created the month levels, and then we've tidied the data up here. So ultimately, we now have our data tidy in historical temperature. Okay, I'm just going to clear these parts at the bottom. So the first thing we want to do is we want to calculate the mean monthly temperatures in the 17th century. So let's call this variable C17th because we can understand that. And we're going to take that from historical temperature, which we're going to push through the filter function where we want the years which are less than 1700 and the years which are greater than 1600. So that's everything in the 17th century. We then want to group by month. And then finally we want to summarise, where we say the temperature should be equal to the mean of the temperature column, where we ignore all of the NA values. Now when I run this, you can see there's a little warning here, and that's because we do sometimes, in some versions of R, do need to say don't worry that the groups are going to be dropped in the summary. So we just add in that dot groups equals drop, and that removes the warning. And if we just have a quick look at what this table looks like, there we are. We now have the monthly average temperatures for the 17th century. Now we can do the same thing for the 21st century. So let's put that in here. Let's call it C21st. But now we're going to do years which are greater than 2000. Obviously, when we get to the 22nd century, we will need to adjust this filter. Okay, so that's the 21st century values. Now there has been a change. How can we calculate the differences? Well, let's place this into a change column within C21st. So let's say C21st change is assigned from C21st temperature minus C17th temperature, like that. And let's print that to the screen. There we are, we can see the change in temperature from the 17th century to the 21st century. So in January it was 2 degrees warmer, going to June it was about 0.8 degrees warmer, which you can see by I 4.7 and 2.5. So we can see the warming for every single month of the year between the 21st and 17th centuries. Now, and obviously you can see the warming is most focused in the winter months, at least for this particular site. Now we can repeat this for the maximum and minimum temperatures to answer the next question. So I'm going to take this as a copy, save myself having to type things out too many times. So instead of doing the mean, we're going to want to do the max. We want to do this for the 21st and the 17th. So this is year is less than 1700 and year is greater than 1600. So we have the max at that point, and then let's put the change in. So C21st change is equal to C21st max, and let's make sure we call these max as well. There we are. So C21st max change is equal to C21st temperature minus C17th max temperature. And then let's print that to the screen. What have I done wrong in this? Oh, there we are. There we are. So spurious little extra there. So we have C21st max, C17th max. We've calculated the difference. We can see the change in the maximum temperature is kind of a little bit more random. We want to do the same thing for the change in the minimum temperature though. Let's copy and paste all of that. And instead of doing maxes, we're now going to do mins. So changed all of those to mins, and we're now going to use the min function. And then if we run, there we can say is actually most of the change is coming in the change in the minimum temperature rather than the change in the maximum temperature, which is quite interesting. Okay, so that's now completed the exercise. And I hope you've noticed that because we were working with tidy data, the filtering and the grouping of observations and then the generating of these summaries was much more straightforward than if we were trying to work with the original kind of untidy data. This grammar of the data was filtered, then grouped, then summarised has worked because the data was tidy. And as we will see in the next section, there's a similar grammar for visualisation, which makes graph drawing equally logical and straightforward. So that's all ready for this section. That's the end of this video, and I look forward to seeing you in the next video when we're going to tackle graphing.